So now that you've seen the ballistic pendulum, let's go through quickly of how you solve this problem using physics. So the bullet starts in the gun. When the bullet fires, the bullet will have some initial velocity, which means when it leaves the muzzle, it's going to have some initial momentum, the 2.55 grams times its initial velocity. We don't know what that is, however, that's the value we're looking for. It then goes into the block, and since it lodges itself in the block, it's going to be in an inelastic collision. So the two are going to stick together. They're going to have some final velocity of the block and bullet together. Well, that gets us part of the way there. Unfortunately, we don't know the final velocity of the block. So we're going to go and switch gears into energy. And we're going to look at how conservation of energy plays a role in this. So the block and the bullet now have some velocity together. We called it the final velocity. But that means that that velocity it has, the block, the bullet together, is going to have some initial kinetic energy. It starts at some height 0, and when it swings up to the angle that it's at, the angle that it swung to in this demo was 26 degrees, we can use that trig, the distance that swings up, figure out how high up vertically it goes. So how much in the vertical direction, how much against gravity, or how much potential energy this gains. The amount of potential energy it gains is equal to the amount of kinetic energy that it had to begin with. So the final potential energy is equal to the initial kinetic energy. The initial kinetic energy was figured out knowing that the block and the bullet together are lodged together. They have the same velocity. That velocity was figured out using the inelastic collision due to the bullet firing into the gun. So by going backwards through that, we can figure out the initial velocity of the bullet.